Hi everyone, I'm back with another video of IGCSE Math Preparation Series. My name is Erfan. By now, you should be familiar with my work. Basically, every time I teach you guys about a topic, the next video after that, it's gonna be the past year paper question regarding that topic. So we're done with sequences in previous video, and now today is time to do a bunch of past year paper questions regarding that. So it's going to be quite lengthy. I think we have about 8 questions to go. So without any further ado, let's start. Question number 1. I challenge you to pause each time you see the new question so that you can evaluate yourself and put your knowledge into test. Question number 1. These are the first 4 terms of a sequence, and they ask us to find the next term. Let's see if we can find any pattern. It seems each term is gradually decreasing. Here I have -6. Do I get 11 if I subtract 6 from it? Yes. So it seems this is an arithmetic in which D, or the common difference, is -6, and my first term is 23. So I'm going to use this information actually to answer part B. However, in part A, you don't need that. The next term, or the 5th term, you just have to subtract 6 from the 4th term and you obtain the 5th term, which is -1. Okay, that carries 1 mark. And for part B, if you recall, for arithmetic sequences, the nth term can be obtained by using this formula, a plus n minus 1 times d, in which a is the first term, d is the common difference, and n is basically the nth term, right? So knowing that, I just substitute these values, which I got from part A, n minus 1 times -6. So don't forget to open this bracket. That simplifies further to -6n plus 6, and eventually we got -6n plus 29. Okay, that's just with easy question. I started this session with easy question, so slowly you will see that the questions are getting more difficult, especially after question number 4. So another sequence and same question, the nth term. Okay, don't let this square root actually deceive you, because it doesn't really play any role here. The number under the radical is actually what we should be looking at. And as you can see, so let's say the square root doesn't exist there, because it's always there, right? So for u and the nth term, it's gonna still be there. However, the number beneath it is changing. So 1, 3, 5, 7. So these are odd numbers basically, and each time we add 2 units, right? So what you have to find is the nth term of this sequence, and then you just put it under the radical, and that's it. We're done. So now I know the first term, a, and I know the common difference. Actually, for odd integers and even integers, there is a shortcut, but since this is the first time you're seeing the topic of sequences, so I better obtain it for you so you know where that formula comes from. So a, which is 1 plus n minus 1 times 2, so you get 2n minus 2 plus 1, which is -1. So this is one way of showing odd numbers, right? And for even numbers, we use the term 2n. Okay, I'm not done. The final answer is square root of this. Yeah, I forgot that. Don't forget there is a square root there. Part B, u25, that's easy, just substitution. So u sub 25 is equal to square root of 2 times 29 minus 1, which is 48, minus 1, which is 47. As simple as that. moving on to the next question, question number 3. So we are given 3 sequences, and for each one, I believe we have to find the 10th term. So this is easy. The first one is just the positive integers starting from 1 all the way to basically 10, right? So the 10th term is 10 because the first term is 1, second term is 2, right? That's easy. This one starts with 7 and goes all the way up to 16. Again, we add 1 each time, right? But we start with 7. So why not 17? 10 units after that, right? This is where some students, they make a reckless mistake. So remember, for the top one, the 10th term, we added 9 to 1 to get the 10th term, right? So you have to do the same thing here. 7 plus 9 is actually 16, right? Not plus 10. So, okay. And then the next one, we start from 8, right? And this time, what you can do, you can actually add number 18 to 8, because for the top one, you add 9, for the bottom one, the difference is 2 each time. Can you see that? So I'm trying to use the shortcut. I don't want to form the UN. However, since this carries 3 marks, yeah, let me show you actually how we obtain what I just said. So the formula is a plus n minus 1 times d. A is 8, d is positive 2, and we're looking for the 10th term. So that would be 10 minus 1, and then times 2, which is 8 plus 18, the one that I just told you earlier, right? So I was trying to do it mentally, but this is how you obtain 26. A is 8, D is positive 2, and N is 10 in this case. Now, in part B, you're given something like this. This is a sequence, which I believe they got help from part A. Let's see what's the relation between B and A. There must be something there. They say write down the next term and the 10th term of this sequence in this format, okay, in which A, B, and C are integers. Let me find the number outside the brackets. So it seems, so these are the whole numbers, right, increasing. So definitely the next one should be 5. Now let's investigate the numbers in the bracket. The first one is 8, then becomes 10, 12, 14. So basically, it's this third sequence here, and the next number should be 16. Each time 2 is added. And let's take a look at the second term inside the bracket. We are starting with 7, 8. Each time 1 unit is decreased, right? Because it's negative 7, then becomes negative 8. So it's negative 11 now. Okay, this is the next term, which I believe it should be 1, 2, 3. This is the 5th term. Now they want the 10th term. This is where you need to get help from part A. These are the numbers that I obtained. So since each A is basically coming from this sequence, and B is coming from the third sequence, and C is coming from the second, so you just have to substitute the 10th term from each of these sequence to complete this answer. So I have already listed the A, B, C here. So A should be 10th term is 10. B is 26. B is from the third sequence, and then minus 16. So the answer is 100. As simple as that. Okay, there is one more part. Write down the nth term. So for that, we need the nth term for each of these sequence. The nth term for the first one is n. The nth term for this one is n plus 6, right? And then the last one is 8 plus n minus 1 times d, which d is plus 2. We get 8 plus 2n minus 2, which is 2n plus 6. So this is n plus 6, 2n plus 6. Now I have to replace them for A, B, and C. A is n outside, B is 2n plus 6, and minus C is n plus 6. And you get n times 2n minus n, that is n, and 6 minus 6, that would be 0. So you would get n squared. Yeah, actually, I should have seen that coming, because if you find the value for these expression, you get 1, and then 2 times 2, 4, and then 3 times 3, 9, and then 4 times 4 squared. So basically, the numbers are getting squared. So this is 1 squared. So the nth term should be squared as well, right? So moving on to the next question, given a bunch of terms in a sequence, and they ask us to find out their summation. So if this is the case, we call this a series. So series is nothing but the summation of all the terms inside a sequence. As you can see, there is no comma here between the terms. That's the difference between sequence and series. So I have to refer to the formula for the summation of all the terms inside an arithmetic sequence, which is n over 2 times 2a plus n minus 1 times d. Now, what I need to do is to find out what is n, because I have a, the first term, and I know what is d. D is plus 1 here, right? D is plus 1, and a is 121. All I have to do is to find out how many terms are they. From 121 up to 200, I can evaluate that by subtracting 121 from 200, and at the end, don't forget to add 1, right? Because we're looking for the number of terms, and that would be 80, right? Now, if n is 80, I'm just going to go ahead and substitute it here. 80 over 2 times 2 times 121 plus 80 minus 1 times d, which is 1. So this is 40. This is 241 plus 79. So see what that gives us. The answer is 12,800. All right. So we have to just use this formula. Okay. The last part of question number 3, they're asking us to find the sum of the even numbers. Again, you can use this formula, but at first I like to make a little bit of modification here. I would like to take out 2, in other words, factor out 2, and I'm left with 1 plus 2 plus 3 plus all the way to 400, right? That's not really necessary, but you can do that. And then what I'm going to do is, because another version of this formula is basically n over 2 times the first term and last term, right? So let's forget about these 2 for a second. These terms, the summation of all these terms together gives me, this is the first term, last term. I'm gonna add them up together, divide by 2, and then times. From 1 to 400, there are actually 400 terms, right? And then you have to multiply everything by these 2 here, which is outside this bracket. So if you do that, this 2 with this 2 is gone, and we have to multiply 400 by 401, and the final answer is 160,400. So I used a little bit of different approach. It's the same formula, but another version of this formula, and the fact that I factor out number 2 from this series. Okay, so you can give it a try and maybe use the original formula to see whether you get the same answer or not. So moving on to the next question, question number 4. the first three positive integers, 1, 2, 3, have a sum of 6. Okay, write down the sum of the first four positive integers, meaning which 1, 2, 3, and 4. So you don't need to add all of them together because the first three is 6. So the fourth one, which is 4, you just add it to 6. And the answer is basically 10. The formula for the sum of the first n integers is n times n plus 1 divided by 2. Show the formula is correct when n is equal to 3. So you just have to substitute. We know the sum of the first three positive integers is supposed to be 6. So if I substitute 3 here, if I obtain 6, then it verifies that this formula is correct. So 3 times 4 divided by 2, that gives us 6. Find the sum of the first 120 positive integers, meaning which from 1 all the way to 120. So you have to find out how many terms are they. First of all, what is n? 120 minus 1 plus 1. So last minus first, and then at the end, don't forget the plus 1. So I have 120 terms, and then go back, use this formula, substitute n as 120. So 120 times 121 divided by 2. So that is 60 times 121, which is 2, that would be 7,260, right? Okay, moving on to next question. Part B of the same question, they ask us to complete the following statements. Okay, I believe the cube should be there. Now 1 plus 2, this is 6, this is 10. This part, we had it from part A of this question, right? And here I have to calculate 1 plus 8, that's 9, plus 27, that is 36. And here, basically, this is 36, 4 cubed is 64 with 36, 100, okay? You can use a calculator for that, actually. So the sum of the first 14 integers is 105, meaning which if you continue this pattern and you reach to 14, this should be 105. They say find the sum of the first 14 cubes, meaning 1 cube plus 2 cube all the way to, okay, at first glance, it's a bit scary, but look, it only carries one mark. It's easy, in fact, because there is a relation, right, between these two columns. Let's see if we can find that the pattern. If this is 1, this is 1. If this is 3, this is 3 squared, which is 9. If this is 6, this is 6 squared, which is 36. If this is 10, this is 10 squared, which is 100. And if this is 105, this should be 105 squared, right? So that's how you find the answer to this question, which is 11,025. So use the formula in part A2 to write down a formula for the sum of the first n cubes. Let's go back to A part 2. This is the formula for the sum of the first n integers. And then for the cube one, because I told you just now, if this is 10, this is 10 squared. If this is 6, this is 6 squared. And if this one for the first n terms, right, if this is n times n plus 1 divided by 2, right, we got that from the first part of this question. So for the cube one, the first n cubes should be this whole thing raised to the power of 2. So n times n plus 1 divided by 2 raised to the power of 2, as easy as that. Find the sum of the first 60 cubes. All I have to do is substitute, because n is 60, so just substitute 60 here and see what it gives us, divided by 2 raised to the power of 2. So just don't forget to raise everything to the power of 2 at the end. You get 3,348,900. Okay, so moving on to the next question. find n when the sum of the first n cubes is, okay, so it means n multiplied by n plus 1 divided by 2. When this thing is raised to the power of 2, it gives us 278,784, right? So I'm going to take square root from both sides because the goal is to find n. So that is 528, and we have n times n plus 1 divided by 2. N squared plus n is equal to 1056, right? So I have to find the value of n, which is basically 32 and 33. This is actually a quadratic equation which you have learned in previous videos how to solve it. You just bring this number on the other side, and you can use AC method for this. The two numbers that when you multiply them together gives you negative 1056, and when you add them together gives you positive 1. I'm sorry, n should be, this should be negative. All right, and this is rejected, so n is positive 33. So moving on to the next question. This is also a common question. The level of difficulty is moderate, I would say. So in the first part, they're asking us to complete this diagram. So each time we actually draw this L-shaped figure, right? For diagram 2, we add 2. For 3, we add 3. For 4, we add 4. And for 5, let me go ahead and complete the drawing. This is what we have in 4, right, already. And I'm gonna go ahead and add how many I have to add. 5. 1, 2, 3, 4, 5. Okay, so that's diagram 5. Purposely, I use another color to distinguish it from diagram 4. This is complete. Now we have to complete the table. So diagram 5 has how many number of lines? Well, 4 already has 20. Just count the green line that I just added, right? The green lines. That is 5 times 10. So 10 plus 20, now we have 30 lines. Number of small squares. So in diagram 4, we already had 6. Now we have, after adding these lines, we have 1, 2, 3, 4. 4 more squares, so this is 10, right? The table is completed. They ask us find an expression in terms of n for the number of lines of length 1 unit in diagram n. This is 30, this is 10. They say number of lines, right? Meaning which this row, right? So if it's 1, it's 2. This is the relation between position to term, between these numbers. 1 is 2, 2 is 6, 3 is 12. So how can we find the pattern? Let me see if we have a D, if this is arithmetic. So each time I'm adding, this is 4, and then 6, and then 8. So this is not arithmetic. However, if you find the second difference, you reach a constant number. So the general form of this sequence is something like this. That's a quadratic, right? And I need to find ABC. In order to find ABC, you have learned in previous video that A plus B plus C gives us this number, 2. 2A gives us this number, which is 2. And then we have 3A plus B must be this guy, the middle number 4. And I got 3 equations, 3 unknowns. Start from the last one, solve it, and work your way up. A is 1. If A is 1, you substitute in the second one, and you obtain B. 4 minus 3, that's positive 1. we have A and B, so C should be 0. If A is 1, B is 1, substitute it here, so C is 0. Now the final format of this quadratic sequence is basically n squared plus n. That's the final answer. Now they want us to find an expression in terms of n for the number of smallest squares. Now it's the second row. This is the second row. I have to find a relation. If I continue here, I get 1, 2, 3, right? The difference is this. Then I continue further. The second difference gives me 1. So again, this is a quadratic and it follows this format. I have to find the value for A, B, and C. So you already know what to do. If I add all these three constants, I should get 0, right? And 3a plus b should give me 1, and 2a should give me 1 as well. So the last one gives us a is half. So if a is half, substitute in the second one, 3 half plus b is 1. So b is negative half, right? B is negative half. And then a is half, b is negative half, c must be 0. So the final format would be half n squared minus half n, which you can take out the half and you're left with half of n squared minus n. You can actually test that as well. If n is 5, we should get 10. Do we get 10 if we substitute 10 instead of n? Half of n squared is 25 minus 5. So that would be half of 20, which is 10. So that's correct. So this is the formula for part D. And question number 6, it's a lengthy question. Part A alone carries 12 marks. So now I've given 5 different sequences. So let's find out what's going on in sequence A. Each time we're deducting 2, right? That's what's going on. So this is the 5th term. The 6th term is 3 minus 2, which is 1. And the nth term, this is an arithmetic sequence. So it follows this format, a plus n minus 1 times d. A is the first term, which is 11, n minus 1. D is negative 2. So you just open this bracket and you get plus 2 minus 2n. So we get negative 2n plus 13, right? And for second one, these numbers are famous, guys. These are square numbers, right? This is 4 is basically 2 squared. This is 3 squared, 4 squared, 5 squared, and 6 term should be 6 squared as well, or 36. And the nth term is n squared. Then sequence C, 2, 6, 12. Okay, here I'm adding 4, but then I increase it by 2 each time. Yeah, that's what's going on. So the next one I should add 12, which gives me 42. So in this case, we get a quadratic because I go up to second difference. The second difference is 2. Now you know what to do. A plus B plus C is 2, and 3A plus B is this guy right here, 4, and 2a is 2. That helps you to find a, b, c. So a should be 1. If a is 1, b should be 1, right? And if a and b are 1, so c should be 0. So what I get is n squared plus n, right? Or if you want to factor out n, you can write it as n times n plus 1. Moving on to part D, what's going on in part D? These are famous numbers as well. These are multiples of 3, basically. The first one is 3 raised to the power of 1, that is 3. The second one is 3 raised to the power of 2, right? I can write this as 3 raised to the power of 1, 3 raised to the power of 2, 3 to the third, and then fourth, and keeps going. So this guy right here should be 3 raised to the power of 5 or 729. And the nth term is basically 3 raised to the power of n, right? We have 1, 3, 15, 61. Now, what is going on here? Well, if you look at the terms of sequence E, it's not arithmetic, right? It's not geometric, and it's not quadratic nor cubic, right? Because if you continue finding difference, the first difference, the second difference, and third difference, you won't reach a constant. I'm trying to figure out a relation between the position of each term and the term inside the sequence itself. However, it's a very tough thing to do right now, but there is a reason, guys. In this type of question, there is a reason they gave you these sequences in this order. So if you look at D and C, so I'm gonna erase this thing now. So if you look at D and C, the terms of sequence E can be obtained by subtracting the terms of sequence C from the terms inside sequence D, meaning which 3 minus 2 gives us 1, 9 minus 6 gives us 3, 27 minus 12 gives us 15, right, and etc. So basically E is D minus C. And we already found the nth term for D and C, and we found the relation between E and these two sequences. And the nth term for E is basically 3 raised to the power of n minus n times n plus 1, right? So that's it. So this was quite a bit, I would say, a challenging question, but you could figure it out eventually if you look at the previous sequences. So moving on to the next part, in sequence A, they want us to find the 100th term. So this is A actually, this is B, this is C, D, and E. So for A, the 100th term would be negative 2 times 100 plus 13, and that gives us negative 187, I believe. For sequence C, again, if n is 100, basically that's 100 squared plus 100, which is 10,000 and 100, right? So moving on to the next question. Find the value of n in sequence D when the nth term is equal to 6,561. So basically sequence D was 3 raised to the power of n. So this value should be equal to 6,561. My guess is that the right-hand side is a multiple of 3, meaning which we're gonna have something like this. So what should I put as the index? You can keep dividing this number by 3 and see how many times it is divided. So you can use a calculator for that. I believe you should get 3 raised to the power of 8, right? If you keep dividing it by 3, we get 2,187. You divide it by 3 one more time, 729. So divided by 3, 243, then 81, then 27, then 9, 3, and lastly 1. So how many times is that? It should be 8, right? So as soon as you figure that out, then n is equal to 8, according to the law of indices and exponential equations, which you learned on previous videos. Part D, find the value of 10th term in sequence E. So sequence E looked something like this, n plus 1. This is basically how much when n is 10. So this is 3 raised to the power of 10 minus 10 times 10 plus 1, which is 11. So 3 raised to the power of 10 is 59,049, which if you subtract 110 from it, you get 58,939, right? Moving on to the next question, another figure, this time concentric circles. So diagrams show a sequence of dots and circles. As you can see, each diagram has one dot at the center and 8 dots on each side. So basically, each time you add a new circle, well, of course, it should be a bigger circle, but the number of dots doesn't change. As you can see, each circle has basically 8 dots, right? So they just get further apart, meaning which the circumference and the area of the circle is getting bigger and bigger. The radius of each new circle is 1 unit greater than the radius. Okay, so we have to complete this table. The first row is basically the diagram, or we can call it as position, right? And the other rows, they are the terms. So first row are the terms of the sequence, and that sequence represent the number of dots, right? Then the next one, area of the largest circle and total length of circumference. So for the first row, which represent the number of dots, I think this is an arithmetic. This is easy to figure it out. 9 plus 8 gives you 17, plus 8 again. So I have to add 8 to it 2 more times. I get 33 and 41 respectively. So the second row, area of the largest circle, pi is always there, of course. There is no change to pi value, right? And the coefficient of pi keeps changing. First it's 1, then 4, then 9. So these two are basically square numbers. 1 raised to the power of 2 is also 1, so we can treat that as a square number in this case. And where does the number comes from? From the positions. The coefficient of the first term is 1 raised to the power of 2. Then 2 raised to the power of 2 give you the coefficient of the second circle. Then 3 raised to the power of 2 gives you 9, right? And this guy 4 to the power of 2, 16, 5 to the power of 2, 25. So you have to find a relation between position and term, okay? That is very important. I'm gonna use the same technique for next sequence, total length of the circumference of the circles. So this is 2, 6, 12. So what is happening? This is 1, the first position, and the term is 2 pi, 2, 6 pi, and 3 is 12. So it seems to me when I multiply these two, 1 and 2 gives me 2, 2 and 3 gives me 6, 3 times 4 gives me 12, right? And then 4 times 5 must give me 20, and the pi is there again. And then 5 times 6. So basically, you take the number from the position and you multiply it by the number right after that, whatever comes after that. So that is 30 pi. So that's the pattern. Probably then they're gonna ask us to find u sub n, or the nth term for each of these in the following part. They say in terms of n, the number of dots in diagram n. So number of dots, which was the first row. So for the first row, what did we do? We just added 8, right, to the first term, which is 9. So this is arithmetic, and in arithmetic, you know, the format is a plus n minus 1 times d. So they want un. We have 9 plus n minus 1 times d, which is 8. That's our common difference here. So I get 8n plus 1. That's the answer for part B. Then they say find n when the number of dots in the diagram is 1097. So we have the formula for nth term. If 8n plus 1 is equal to 1097, how much is n? So n should be obtained by dividing 1096 by 8. How much would that be? 137. So that's n. It carries 2 marks. So next question, write down in terms of n and pi, the area of the largest circle in diagram n, in diagram 3n. If you recall, let me go back to the, for the area, this was the pattern. And what we did, we just raised this number to the power of 2. So un would be equal to n squared pi, right? Don't forget that we have a pi. Just the coefficient of pi is n squared. Okay, moving on. What did they say? For diagram n is this, and for u3n, so basically instead of n, you just substitute 3n. So 3n, the whole thing is squared. So that's the tricky part. Don't forget pi and 3n raised to the power of 2. So that would be 9n squared and then pi. So that's the answer for the second part. Moving on to the last part. So what do we have to find out this time? In terms of n and pi, the total length of the circumference of the circles in diagram n. So again, the nth part, as I suspected that they might ask us. So this is the row, this is the terms of this sequence. So they're asking for u sub n or the nth term. If you recall, how did we obtain these coefficients? For example, 20 was obtained by 4 times 5. So this is the fourth term, right? How did we obtain 24 times the number after that 5, and there is a pi there. So for u sub n, we should multiply n by the number after that, which is n plus 1, and then there is a pi. So expand this, u sub n is equal to n squared plus n, and then times pi. You can leave it as this version as well, n times n plus 1 times pi. So both is correct. I hope we're done with this question. Yeah, so let me clear out everything. Question number 8. All right, this is a little bit different from the previous question. So you shouldn't always be expecting to be given the terms and then find the nth term or the formula for that sequence. As you can see, they gave us here the formula. So the rest is easy because each time you just have to change the value of n, substitute it, and you find the answers. So you shouldn't be expecting it to carry a lot of mark. Like previous question, it carried 12 marks for this, completing the table. Okay, n is 2. Let's do it quickly. 2 cubed is basically 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And then that is 4n. So n is 2. 4 times 2, 8. N is 3. 3 times 4, 12. N is 4. 4 times 4, 16. N is 5 times 4, 20. Now n plus 1 squared. So n is 2. When you add 1 to it, 3. 3 squared, that is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36, right? So you don't even need a calculator for that. You can do it quickly. In part B, find the 8th term of sequence A. Again, very similar. Now they just want u sub 8, which is 8 cubed, basically, right? And 8 cubed is 512. The 12th term of sequence C, so u sub 12 is equal to, this is the formula, so 12 plus 1 raised to the power of 2, that is 13 squared, which is 169. Which term in sequence A is equal to 15,625? In A, which is n cubed. So this number, we put it equal to n cubed and see what it gives us, 15,625. Take the cube root from both sides. So for that, I need my calculator. The answer is 25, right? Okay, moving on to the next question. Which term in sequence C is equal to 10,000? So sequence C, this is the formula, n plus 1 raised to the power of 2. So this is a good practice of solving equations. So this question is more like solving an equation. So I have to take square root from both sides. The right-hand side, I know it gives us plus minus 100. However, guys, algebraically, this is correct, but here it doesn't make sense. The term could be negative, but the position of the term cannot be negative. That doesn't make sense. So you don't need to put plus minus there. You just put 100. Therefore, n is 99. That is the 99th term. Its value is 10k. Now we have to complete a table, 2 new sequences. Let's see what's going on here. As you can see, the terms are a little bit weird. I cannot see any relation between them at first glance. Even if I find the difference between them, the first or second difference, I won't reach a constant. Something similar in previous question. If you recall, there was a connection between the last 2 sequences in the table and the first sequences that we had. So maybe we can find a relation between sequence D and one of these 3 sequences A, B, C. So it seems the terms in the sequence are obtained by adding the terms in sequences A and B. Let me see if that's correct. Okay. So yeah, that is correct, because 1 and 4 gives us 5, 8 and 8 gives us 16, 27 and 12 gives us, so that is correct. It means the 5th term, we should add the 5th term of sequence A and B together, which gives us 145, and the nth term would be basically n cubed plus 4n, right? N cubed was from sequence A, 4n was from sequence B. Now, the last sequence, E, well, I can't see any connection between E and previous sequences. However, if you look at these numbers, okay, I can rewrite this as 0 to the power of 2. This one I can write it as 1 to the power of 2. This guy as 2 squared, 3 squared, 4 squared, right? Okay, the nth term should be okay, there must be a connection between these 2 numbers, 3 and 2, 4 and 3. As you can see, these numbers are 1 unit less than the position. So if this is the nth term, this should be n minus 1 squared. So as simple as that. This is the last question. I think this is a good place to stop. I hope you have enjoyed the video, but don't stop here. Go ahead and do a couple of more questions regarding sequences from past year paper questions, and maybe you can share your ideas in the comments below. Thank you guys. Stay safe. See you in the future videos.